The next question is, consider a hexagonal lattice with a basis vector as shown in the figure. They are given the two basis vectors, one is a1, another one is a2. If the lattice spacing is a is equal to 1, the reciprocal lattice vectors are they are given the four options. The four options are 1, 2, 3, 4. We have to check which one is the reciprocal lattice vector. First, we can find the real lattice vector. What is the value of a1 and then what is the value of a2 in terms of lattice parameter. Already we know the hexagonal lattice, the sides spacing a as well as from the center to the all the corners the spacing is a. Now we want to find the value of the given vectors. So there are they given the two vectors. One is this a1. First we can find the a1. Already we know the lattice spacing is a. So the vector a1 is it's a sum of the x1 cap. Suppose here y direction, this is the x direction, x1 cap plus sum of y1 cap. But what is the value of the previous coefficient of the x1 cap as well as y1 cap? That means the length in the x1 direction. So the vector is up to here. So if you are projecting the coordinate, if you want to take this distance is a by 2, this is a, total is 3a by 2. So the x is 3a by 2. So now we want to find the y distance is nothing but this is a, not a, it's actually square root of 3a by 2. You can check using the coordinate system. This is square root of 3a 3a by 2. Now same way we can find the asking vector square. What is the a2, the real lattice vector? So the this distance is a by 2. So this distance is a. So the this distance is square root of 3a by 2. If you are using the Pythagorean theorem, you will get it. So same way this distance is square root of 3 by 2. So only y direction will exist. So the vector a2 should be equal to only y direction is exist. You can call it as this is y2 or x y, no, not y1 y2, a1 a2 you can specify. The unit vectors are x and y. Here a2 only in the y direction, but square root of 3a by 2 plus square root of 3 by 2, the total length in the y direction of the a2 vector is square root of 3a. So now we found the two real lattice vector. One is the a1 is 3a by 2 x cap plus square root of 3a by 2 y cap. Then a2 is the a2 square root of 3 x cap only, not x cap, it's y cap. So this is square root of 3 a y cap square root 3 by a by 2 square root of 3 a by 2 x cap as well as y cap. So we found the real lattice vector of the given hexagonal lattice. Here a, the sides are 1, so you can take an a as 1. So the after substitution you will get 3a by 2 x cap square root of 3 by 2 y cap. Substitute a equal to 1, so this will become 1. So a2 equal to square root of 3 y cap. So we know the only one relation. The relation is the real as well as reciprocal lattice vector relations. Suppose if the corresponding reciprocal lattice vector for A1 is B1, this is real lattice, this is reciprocal lattice. The reciprocal lattice is B1 for the corresponding E1. For A2, it is B2. What we want to check is the relation between these two vectors are A1 into B1 should be equal to 2 pi. We want to check this one. Next one is A2 B2 is equal to 2 pi. Because the real as well as reciprocal lattice vector, if you are finding anything, suppose n is the number of real lattice vectors a1, a2, a3. Maybe if 3 dimension 3 vectors, 2 dimension 2 vector, 4 dimension 4 vector, it will go in case according to the number of dimensions. Same if for bn reciprocal lattice vector, it will form the Kronecker delta. Delta n, if you are taking this as m, whenever n and m are equal, then it will form 2 pi. So this we have to check for the given answer. Once if it is satisfying with this, then our answers are right. We can check with the first one. So the first answer here they are given b1, that means reciprocal lattice sector b1 at 2 pi 4 pi by 3 x cap. The b2 minus 2 pi by 3 x cap plus 2 pi by square root of 3 y cap. We can check the first one, then we can move other options. So the first option, if you are checking a1 and b1, suppose a1 is here, b1, if you are taking dot product these two, so what you will get means the a1 is 3a by 2 x cap, that is 1, a is 1 square root of 3 by 2 y cap dot b1 is 4 pi by 3 x cap. So what you will get, x dot x1 3 will get cancelled, so it will form 2 pi. So it is forming. Next check is a2 dot b2. So here b2 is this one, a2 is this one, so we can write it a2 is square root of 3 y cap, b2 is the given answer for b2 2 pi by 3 x cap 2 pi by square root of 3 y cap is equal to, if you are taking, there is no x cap, so it will be 0, but y cap is, it exists, square root of 3 will get cancelled, answer is 2 pi. So the first option is satisfy the condition. So the right reciprocal lattice vectors are b1 as well as b2. The first option 1 is right. You can check a1 dot b2 goes to 0. You can check this condition also, because it's the Kronecker delta. The real lattice vector 1, reciprocal lattice vector 2, if you are taking dot product, it should satisfy the Kronecker delta relation. We can check these properties also. Your a1 is nothing but 3 by 2 x cap plus square root of 3 by 2 y cap. This is a real lattice. Dot b2 reciprocal lattice from the answer minus 2 pi by 3 x cap 2 pi by 3 square root of 3 y cap. So if you are checking these relations, you can cancel for x dot product, you can cancel these two, you can cancel this one also, so minus pi it will come, plus y cap, if you are this will cancel, this is cancel, so plus pi it will come, it is 0. Same way you can verify the another relation, a2 cap b1 should 0. You can check all these three relations. So the given first answer satisfy all the relation. First, what we have to calculate the real lattice vector. We should know how we have to calculate. Once if we are calculating these two, we can verify this property. We can get the best answer. So option is 1.